All right, here we go. First video of trying to figure out some net forces with accelerations. This one's going to include angles, so if that's too spicy for you, then we'll have to try something else, but you should be able to tackle some angles at this point. So here's our scenario. We've got Kelvin's accelerating to the left, see, acceleration, at zero point 0.3 meters per second squared. Hobbs is pulling him back at an angle of 60 degrees. See, look right here, 60-degree angle. I swear it's there. I know it looks totally vertical, but we're just talking about this part right here. If the ground is applying a force of 50 newtons on Kelvin, so that's, the ground supporting him, what is the force that is moving Kelvin forwards? Okay, so that's what you're trying to figure out. What is the force that's moving Kelvin forwards? So pause the video, try and solve that on your own, come back, check, see if you got the answer. All right, so pause video and checking in 5, 4, 3, 2, 1. Bam, there's your answer. Now, it's actually friction, because if you remember, like cars on a tire, when you walk, when you push backwards, friction actually pushes you forwards. So it's friction with the ground that's allowing you to move forwards. So I called it friction. So don't be freaked out by that, because that's actually the truth. But the answer is 149.87 newtons. So if you got that, awesome. I mean, if you called it like something besides friction, I can live with that. Don't worry, I won't judge you. But if you got that answer, you're in great shape. If not, let's start walking through how to get there. And I'll reveal door number 1, which I'm going to bet you know what it is. No, don't. Sneaking. Yeah, you're right. It's a force diagram. It's a force diagram. So let's see if I got the same force diagram that you got. So here we go. Force diagram time. Boom. All right. So there's my force diagram for Kelvin, and you can figure out what forces are acting on Kelvin. So we've got the ground pushing him up, friction, which, like I said, is the ground pushing him forward, and then gravity's pulling him down, and then we've got Hobbs pulling an angle. So we have a y component of that force of tension and x component of that force of tension. So this is the correct force diagram that you should have. All right, so if you don't have that, fix it, see if that lets you solve this problem, and we'll kind of go from there. So again, pause the video and see if you can fix it. If not, I have my net force equations on the way. So let's see what I did next. Let's see, what's behind door number 2? Door number 2 is... the force of tension itself. And I'm going to actually reveal both these boxes, because quite frankly, I did this kind of at the same time, and I want you to think that there's a right way and a wrong way. So let's do both boxes. I'm going to do this both boxes. Be prepared. Boop. So you do a net force equation in each plane. All right. And you might think, hey, it's unsolvable because I don't know the force of tension and I don't know the force of friction. It's just there's too many variables. So if you look in the y plane, though, there's no vertical acceleration, so they equal 0. So I don't know I know the normal force is 50, because that's what told me the problem. Tension is an unknown variable, but I can write, since it's the y component, I can write it as the component. And since I took it from that angle, force tension times sine of 60, that's the y component. Minus gravity, because gravity is pointing down, equals 0. I can then solve for the force of tension, which is good to know. It's not the answer, but it's good to know. So now if I look in the y plane, the x plane, there we go, then there is acceleration. So I have sigma f of x equals ma. So now I just have to say, well, what's in the x plane? Well, friction's pointing back, tension's pointing forward, but it's, again, the x component. So I have to cosine of my angle. Set that equal to ma, and now I'm off and running. Because I know tension from over here, I can bring it in over here, and then the only unknown variable is this, what I called the force of friction, whatever is driving him to the left. Then you can solve for that force of friction. So never fear too many unknowns, because you can now totally have 2 unknowns, because you have 2 planes you can work with. You can work the x plane and the y plane. So if you have 2 unknowns, it's not a problem, because you have 2 equations. All right. So hopefully that all worked out for you and made some sense. And good luck on taking those assessments. Peace.